Hi, everybody. I'm going to try to go over the study guide for the final with you to see if that might help you in your studies. Let's go ahead and just jump right in. We'll get through it. Communication is a common use of artificial satellites. They send and receive electromagnetic waves to transmit radio, telephone, and TV signals. Internet services use satellite signals. People use internet in the home to replace some of their older technologies. Identify which items people can replace by using the internet. Select items from the picture to the right. So if you look at the picture to the right there, this used to be kind of like a drag and drop kind of thing, but this is just the review now. So you look at the satellites, they're replacing some of the things in this room here. Well, what do they replace? Books and newspapers, couch and bookshelf, carpet and newspapers, or none of the above? If you think about it, internet is people go to it. I mean, I've been going to it all morning for news, so it kind of replaces a newspaper. And the internet also has books on it, so it would be A, books and newspapers. Sarah, number two, Sarah is an avid reader and is looking to purchase a Kindle. She reads some consumer blogs and reviews about the newest version based on the following information, sort phrases into pros and cons. Now, you know, a pro is something that's good, positive, and a con is something that's bad and negative. So let's take a look at the pros and cons here. Lightweight, is that a pro or a con? I guess if you don't want to lug something around, that's a pro. Requires an overnight charge. Well, oh man, I've got to charge that thing again. That's a con. More expensive than books. Yeah, that Chrome. A Kindle is more expensive, so that's a con because I want to save money. Holds multiple books. That's a pro, so I can put a lot of books. It's like a little mini library. Rubber back case for friction grip. That's a good thing. I can hold on to it then. Requires Wi-Fi to read. Well, if I'm in a place with no Wi-Fi, that would make things a little complicated. So that's a con. I can read a book anywhere. Backlight to read at night. That's a good thing too. That's a pro. All right, let's take a look at this one. Jackson experimented with two different types of fertilizers to learn which helped tomato plants grow best. He used 3 tomato plants of equal size and gave them equal amounts of water and sunlight. Plant 1 received no fertilizer. Plants 2 and 3 received equal amounts of either fertilizer A or B. Dominic observed the plants for 4 weeks and recorded the data in the chart below. Write an inquiry question for this experiment. Well, the inquiry is the thing, like you're a question that you're asking or you're trying to answer, right? So, what is Dominic or Jackson trying to do here? He's actually, well, it's Dominic and Jackson. Their names changed halfway through the question. Well, his inquiry was, what would happen if I changed fertilizers for the plants? How, or so his question could be, how does the different type of plant fertilizer affect plant growth? That would be an appropriate question for that. 4, make 2 quantitative observations. Quantitative involves numbers, if you remember that from early on. Well, you could say plant 1 grew 3 centimeters between week 1 and week 2, because if you look at it, it started out as 5, went to 8. So that's an observation. It grew 3 centimeters between week 1 and week 2. Another quantitative observation that you might use is that the experiment lasted 1, 2, 3, 4 weeks. Number 5, this experiment is an example of an open system. How could Jackson make this a closed system experiment? Why would that be important? Well, an open system means that it's not sealed off. In other words, things can get in and out. So in this experiment, like maybe bugs might come and land on the plants and start sucking the juice out of the plants and affect the experiment. Maybe some days are cloudy and some days are sunny. That might affect the experiment. Whereas if you turn it into a closed system, you might say, well, in that case, he could put it in a mini greenhouse and turn on plant growing lights for the exact same amount of time every day. And he could make sure that no bugs get in or out. And that closed system would actually reduce more of those external variables, we call them, to make the experiment more accurate. Number 6, this was a good experiment. Jackson wants to explore another method to help tomatoes grow besides fertilizer. Based on Jackson's results in the experiment, how could he set up a new method to grow tomato plants? Well, he experimented with the fertilizer, but is there anything else that he could experiment with as well? Like perhaps amount of sunlight or how much water he gives the tomatoes, maybe variety of tomato plants. Those all can make a difference. Number 7, Ali is performing an experiment on densities. List the liquids from least dense to most dense. Well, if you remember what density is, it's how tightly packed together the particles of something are. So if something's more tightly packed together, it's more dense. For instance, a rock, if you throw it in a swimming pool, it sinks to the bottom because the rock is more dense than the water. So if you look at these three liquids here, honey, water, and oil, the one with the most density, where do you think it's going to go? Yeah, that's right, down to the bottom, and the one with the least density will go to the top. Explain why you arrange the liquids in this order. Well, I guess for that reason. Number 9, Ali measures the mass of the beaker to be 5 kilograms. If Ali gave this to her uncle, who is an astronaut, and he was able to bring this to the moon, which is about 1/3 the size of the Earth, how much would this beaker's mass be and why? Well, in this one we have to think of what mass is. It's not weight. Mass is the amount of matter in something. Now think about what that means. The amount of matter in something. So if I'm made up of, let's say, a trillion atoms here on Earth, if I go to the moon, am I made up of less atoms there? No, I'm still made up of the same amount of atoms. So when Ali sends his beaker to the moon, the mass is going to remain the same. It's just the amount of matter in it, and it's the same. And this is number 10, would the weight of the beaker be more or less than the mass of the beaker on the moon? Well, what is weight? Weight is the pull of gravity. Now you think about it, you stand on a scale and you see your weight. Why do you see your weight? Because gravity is pulling you down on the scale and it makes the you know, lever go up. So on the moon, since there's less gravity, it will pull less on the beaker. Therefore, the beaker won't